Good day to everyone. We are from Group 7. We'll present about our equipment which is shut-off valve. This valve function is to control the fluid flow. So let's go to the first part.
Hi, very good day. I am Muhammad Amar bin Anwar. My metric number B0921101164. So before I state the symptoms that have in the equipment, I would like to explain how we collect all the information. So basically, we are using a diagnostic and troubleshooting procedure for this assignment. Let me explain about it. The first procedure. Visual inspection is the first procedure for DNT. So this involves examining the system or component for any visible sign of damage, wear, corrosion, leaks, or misalignment. So students use a visual inspection first. Then the second is we are using a measurement and testing. This may involve measuring a parameter such as temperature, pressure, vibration, noise, or fluid flow rates. But on our equipment, which is the shut-off valve, we are using pressure gauge, water pressure gauge to measure. And then the next is performance evaluation. This can include assessing factors such as the efficiency of the component, speed, torque, energy consumption. We can see whether it in good condition or not. And the fourth is a data analysis, which compare a statistical data or trend analysis with a reference. And next is fault localizations. Once potential issues are identified through data analysis, we can pinpoint the exact location or component responsible for the problem. And of course, we are using a root cause analysis. But during this assignment, we use a simple root cause analysis and not involving advanced diagnostic techniques. And lastly, after all the procedure, we must do the corrective action, which is repair, maintenance, lubricant, alignment, and make it as good condition. So, here are the symptoms that we recorded, which is have 5 only. First, as you can see, after we use a visual inspection and run the valve, we notice that a medium area has unusual noise occur. So this indicate that the valve has a defect and problem. Next, the second is we test the shut-off valve using a water pressure gauge, as you can see. This is one of the diagnostic tool. We cannot use advanced methods such as vibration analysis because it is only used on rotating equipment. So in this equipment, we only use a simple diagnostic tool, which is the water pressure gauge. The pressure gauge shows a pressure drop, as you can see in the video. This classified as the equipment is defect. Also, we pump the water to the valve according to the reference shut-off valve pressure, and according to the reference, it must maintain at 20.8 Pascal. But the video testing shows the pressure drop slowly. It indicates it ever leaking on the medium of the valve. If the valve use gas, we know the gas will vaporize to the outside, and this is very dangerous in the real world stations. And it must have something problem inside the valve component. So we must study and diagnose it what we can do. After that, student deassembled the valve and found the faulty location, which is the flat seal on the gland press. Gland press is on the medium of the valve. It already wear and tear. Next, I will talk about the damage mechanism from the symptom that I have talked before. So how it will damage the shut-off valve operations. The first symptom damage mechanism is unusual noise, maybe misalignment or deformation of internal components. When unusual noise, we can know the equipment is not good condition and the efficiency will drop. Leak in the valve damage mechanism, faulty seals or gasket. So this seal is possible for creating a tight seal when closed. Escaping fluid, loss of pressure and potential environmental hazard or system inefficiencies. Pressure drop. Damage mechanism is partial obstruction or internal blockage. Reduced flow efficiency leading to a decrease in system pressure. Corrosion or rust. Damage mechanism, corrosion of valve body or component. Potential material degradation and compromise valve performance. That is the effect. And lastly is excessive wear. Damage mechanism wear on valve components. Continuous friction and mechanical stress on components like the stem, disc, or seat can result in wear, reducing the effectiveness in the valve over time. So that is a damage mechanism from the symptom that we recorded. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Mukri bin Ismail. So, this is the cause root of failures. First of all, the cause root of failure is loss of components. Over time, the interval component of shut-off valve, such as stem, washer, or nuts, might become loose. So, this can result in rattling or vibrating noise when water flows through the valve. Second is installation issues. The installation with incorrect, such as misalignment, improper setting, or inadequate support of shut-off valve can lead to operational problems and pressure drops. Besides that, the exposure of moisture also the cause of the failure root. If the shut-off valve is located in an area where it is constantly exposed to the moisture or water, it can lead to corrosion over time. So water can cause the metal to oxidize, leading to rust and formation. For the next point is high flow rates, which is excessive flow rates can cause the increased wear and tear on the valve components. If the valve is not designed or rated for the flow rates encountered, it can lead to premature wear. Over time, the seals or O-ring inside the valve can wear out, so leads to the leaks. These components are crucial for ensuring a tight seal when the valve is closed. Next, the loose connections. If the connections between the shut-off valve and the pipes are not fitting properly tightened, it can result in leaks. So, ensure that all connections are secure and properly sealed. Lastly, high water pressure. Excessive water pressure can put strain on the shut-off valve. It is causing it to leak. Installing a pressure regulator can help mitigate these issues and protect the valve from damage. That's all the cause root of failure. Thank you.
Assalamualaikum and I greet to Dr. Azazi. Allow me to introduce myself. My name is Yap Changming from the course BMKM and my metric number is B0921102113. Today I'm going to talk about the corrective action of shut-off valve based on the possible root cause or failure of shut-off valve. First of all, allow me to start by asking a question. Do you know what is the meaning of corrective action? Most of us will generally think that corrective action is an action of fixing a broken components or machine. But in the engineering definition, corrective actions refer to the systematic process taken to identify, analyze, rectify problems, non-conformances, or deficiencies in a process, product, or system. The primary goal of corrective action is to eliminate the root cause of an issue, prevent its recurrence, and ensure continual improvement. It is a key component of quality management systems and other organizational frameworks aims at maintaining and enhancing product or service quality. Now let's get into the topic. The first possible root cause for the shut-off valve is lossless components. The corrective action for fixing the lost components are use proper instruments like pliers or wrench to tighten the loose parts. During the tightening actions, also remember to take care not to over-tighten, since this may lead to harm. Hence, consider using Teflon tape or thread sealant on the threads before tightening if the loose components have threaded connections. This helps create a watertight seal and prevent leaks, which will more effectively prevent the problem of water leakage. Installation issues refer to the connections are not properly tightened during assembly or the valve itself is damaged during installation. This may lead to water leakage in the futures, so it is important to ensure that the correct installation of shut-off valve and all the connection is secure to prevent water leakage. The first action to prevent installation issues are ensure that the shut-off valve is properly aligned with the part it is connected to. Misalignment can lead to leaks and other issues. Adjust the valve positions as needed. Next, ensure that the shut-off valve is installed in the correct orientation. There are specific designs for vertical and horizontal installations. Installing it incorrectly may affect its functionality, which will lead to water leakage. When the shut-off valve is constantly exposed to moisture, it may lead to rust formation. The corrective action for these types of issues is that when rusting form on the shut-off valve, use a wire brush, abrasive pad, or sandpaper to remove the surface rust. Presenter to avoid damaging the valve material. If the rust is intensive, consider using rust dissolver or a rust converter to treat the affected areas. To stop the valve from rusting further, treat it with a corrosion-resistant material or apply a rust inhibitors after cleaning. This procedure is particularly crucial if the valve is in an environment prone to moisture. Next, what corrective actions must be done if the shut-off valve has a high flow rate problem? High flow rate problems basically causes by the debris or blockage of pipes. Therefore, when the problem of high flow rate occurring in the shut-off valve, we must first check the valve and the pipes that are linked to it for any debris or blockages that could be causing unrestricted flow. Clean or remove any blockages if found. Next, excessive flow rates may be related to high water or gas pressure in the system, so install a pressure regulators to control and maintain the desired pressures can also solve the high flow rate problems of shut-off valve. Besides that, worn-up seals or O-ring is the most common issues that will be occurring over time in the shut-off valve. When choosing the replacement seals or O-rings, we must also choose the replacement seals or O-ring that match with the specifications of the original components. It is important that to use the materials compatible with the type of fluid or gas the valve handle. Before installing the new seals or O-rings, we must also apply a small amount of compatible lubricant to ensure proper sittings and reduce frictions during operations. Carefully install the new seals or O-ring in their designated positions, making sure they are properly seated and secure. Moreover, the corrective actions for the age and wear of shut-off valve are disassemble the valve if necessary and inspect the internal components. Because some of the shut-off valve is used for a long time, therefore it is crucial to inspect the internal components to look for any wear and damage of the components. So, if we find out that there are damage or wear internal components, we must directly replace any parts that show signs of wear or damage. If the valve has moving parts, apply suitable lubricant to ensure the smooth operations and reduce frictions. This can help extend the life of the valve. If the valve is significantly aged and showing widespread of wear, consider replacing it with a new one. A modern valve may have improved materials and design, offering a better performance and durability. Finally, if the valve has components that are visibly damaged due to chemical exposures, for example swelling or corrosions, replace those components promptly. Commonly affected parts include seals, gaskets, and internal components. Hence, also consider upgrading the valve to a modules made from materials that are more resistant to the specific chemicals being used. Consult with the valve manufacturer to identify suitable alternative. Depending on the severity of the chemical exposure, consider installing a chemical-resistant lid linings or coatings on the valve surface. This can provide an additional layer of protections against corrosive substances. That concludes my talk for today. Thank you for listening. I hope you may gain some valuable information from it. Let us now proceed to watch a video on the corrective actions taken by a leaking shut-off valve. Water seeping from the shut-off valve might be caused by loose components. As a result, we use a wrench to tighten up all the hexagon screws to ensure that all the components of the shut-off valve are snug together and there are no open areas for water to flow out. Furthermore, the leakage at the hose location is primarily caused by damaged or worn-out seals that do not perform the required role of preventing the water from leaking. This sort of issue can be resolved by changing the seals that correspond to the shut-off valve requirements. Before installing the replacement seals, a small quantity of appropriate lubricant can be used to guarantee good seating and decrease friction during operation. Following all of our repair actions, the shut-off valve now functions correctly and there is no water shipping out during the leaking test.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hani Muhammad Shamim bin Mazli. I would like to present about the slide preventive action to avoid repeated case. The first, we have know what is preventive maintenance. Preventive maintenance refer to scheduled performance inspection, repairs and upkeep activities performed on equipment or system to prevent breakdowns, reduce the risk of failure and ensure optimal functionality over time. The second is, we have know why preventive maintenance is important. First is to minimize breakdown, extend equipment life, optimize performance, enhance safety and cost saving, and maintain quality product. There are few types of preventive action to avoid repeated case. The first is regular maintenance. Regular maintenance is create a routine inspection and maintenance program for the shutdown valve system. This include looking for wear, corrosion or leaks. Regular lubrication of moving parts and repairing worn out components can help keep minor problem from becoming severe failure. Maintenance should be performed by trained individuals who follow manufacturer specification to ensure that the valve function. The second is the quality components. Invest in high quality valve and other relevant components. Choosing corrosion and wear resistance is critical for longevity. High quality valves are less prone to failure and are built to withstand the system operational needs. The initial investment can result in long-term dependability and reduce downtime. The third one is proper installation. Ensure valves are placed appropriately and per the manufacturer's requirement. To avoid component stress, proper alignment and safe mounting are required. Deviation from the prescribed installation procedure can result in premature wear, leaks or malfunction. Following installation instruction to the later improve the overall efficiency and durability of the shutdown valve system. The fourth one is monitoring and testing. Install a reliable monitoring system to regularly evaluate the functionality of the shutdown valve. This involves monitoring for pressure functionality, temperature change, and abnormal situation in real time. Periodic testing such as valve cycling and leak checks aids in the early detection of potential problems. The system dependability may be maintained and unexpected breakdown minimized by remaining proactive through monitoring and testing. The last one is training and awareness. Provide throughout training to those in charge of operating and maintaining the shutdown valve system. Knowledgeable personnel can recognize early warning sign of problem, perform routine checks, and efficiently respond to valve-related difficulties. This training should include information on correct usage, routine maintenance method, and troubleshooting approaches. Developing a culture of awareness and accountability among employees is critical for avoiding human errors that could lead to system breakdown. That's all from me. Thank you.
In conclusion, diagnostic and troubleshooting empower students to delve deeper into the health of shut-off valve, providing valuable insight into the condition of internal components, fluid system, and overall functionality. So, this assignment teaches students that diagnose and troubleshoot are very crucial in real-world situations because some equipment will give hazard to the employee, and by doing that, it will lower the percentage injury and increase efficiency of the components. That's all from us. Thank you for listening.